In some ways, the bitwise operators are similar to the logical operators. But in this case, the operators operate on individual bits rather than whole values, and the results are always bits rather than a statement of truthfulness. The bitwise operators are often used when interacting directly with hardware, such as for a device driver, because they allow efficient communication through machine registers, or when you are dealing with packed data structures such as those found on storage devices for file systems, and when implementing network protocols such as TCP/IP. The bitwise AND operator delivers a set of bits where each bit is 1 if the corresponding bits in the left and right operand are both 1. The bitwise OR operator produces a set of bits where each bit is 1 if either or both of the corresponding bits in the left and right operands are 1. Now the exclusive OR operator produces a set of bits where each bit is 1 if either of the corresponding bits in the operands are 1, but not if they are both 1. This might also seem like a bit of an obscure operator to have as part of the core language, but for the fact that it is vitally important for many high-performance algorithms, from hashing and encryption to graphics. Keep in mind that all of these operations map directly to machine instructions, so they are very efficient. The left and right shift operators produce a set of bits where the bits of the left operand are literally shifted left or right a certain number of bit positions, depending on the value of the right operand. The main difficulty when using the bitwise operators is in visualizing the bit values, since C does not provide a literal representation for binary numbers. Programmers often use hexadecimal notation as the next best thing. Anyway, consider the numbers 170 and 90, which have these bit patterns, given an 8-bit byte of storage. 170 and 90 produces 10, as in 170 AND or bitwise AND 90 produces 10. This isn't at all obvious until you look at the bit pattern. As you can see, 10 is the decimal value that is produced in the resulting set when you consider only those bits that are 1 in both 170 and 90. I won't try to describe the rest, as it's far easier to grasp simply by studying the table of binary values. Take a moment to look through the results and make sure you understand how the resulting values were produced.